So hello everyone and welcome to my channel. Let's learn with us. Today topics is hubs and switch. Basically, we talk about many things in our previous videos, but now we're gonna talk about hubs and switches because this is a very important topic. And beside important, it also cover some weightage, and it is become important because there is so many things we have to see in it. Okay, so let's start. K- So the first question which came in our mind is can a PC works as server? Because as we know, again a word comes server. Okay, we say that this server that server. So question comes to our mind that PC can work as server. Yes, PC can work as server because what is a server? A server is a process in which uh, as long as it provide to client. Okay, you can see as long it provide to client means the server, the service. As long as it provide the service to the client, we can call a PC or laptop as server. Okay, so where's confusion? If so basically the PC is only the server. No, there are dedicated server and the simple server, basically. Okay, so while calling PC a server isn't wrong, it is important to clarify the scale and context to avoid confusion. Okay, so basically broadband. So this thing has to be noted. Yeah. So basically, a PC and laptop can work as a server, but you have to know that there is a dedicated server in which basically a more profound or more dedicated things are being done. Okay, PC can you can say PC as a small server or simple server or converted server. But okay, but dedicated server are different, where basically sack and sacks of layer of hardware are being deployed to basically do the specific task. But as we all know, in PC we do multiple tasks. We do editing also. We do gaming also. We do streaming also, and many more things. Okay, so these things we have to know. Now, second thing is that one things also came over mind that this is a hub. As you can see, this is a hub and switches. Okay, so you are just asking why, sir, you are just starting from the server and all that, because these are some important topics that we also have to be covered to understand what really hub and switches. In follow on, we cleared that topic also. Okay, so this is a switch. Now the thing is that hub and switch to the same work. Okay, so let's start with the hub itself. Okay, so hub, what is really a hub? So hub is a basic networking device that connect multiple computer or network devices in a LAN, local area network. Its primary function is to transmit data packets received from one devices to other connected devices. Okay, so basically what it do the transmit of data packets from one devices to other. This is what a hub do. Okay, so now the question arises is, so this is basically a hub. Okay, so now question arises is that why really we want a hub, and why hub is being designed. First of all, who designed the hub, and why the reason of hub, why it's been made. So basically in 1960s or 80s, the hub concept developed by uh, in America. Basically the reason is to develop is to transmit the data, to transmit the data packets, because at that time we don't have WhatsApp and all that thing. Okay, even having WhatsApp in today world, in today 21st century, the problem with the software is limited, because like if there is a hundreds of computer, and if you have to transmit the long amount of data, for example uh, in GBs, in for example 300 GB, 1000 GB, 2 TB. Okay, so in that amount you cannot possibly transfer it with software itself, or in using Wi-Fi, etc., because there is a limitation. Okay, that amount of data, even if you transfer it, there is a very lag, and it cannot process it, and the fast is the speed is very slow. So what they do is basically they introduced the concept of LAN or hub or switches. Okay, so what a hub do? Its features, basically it broadcasting. A hub send the same data to all devices in the network regardless of intended receipt. This can lead to network congestion. Okay, so what it do, basically, if you are, for example, there are multiple computer, PC1, PC2, PC3, PC4. Okay, and from PC1 to you want to send the data to PC4, so it transfer through hub. Basically PC1 send data and it transmit all the data, basically all the data together. Okay, I will give you some example. So yeah, sorry for about. So basically what, so this is the best example. Okay, you can see that in image. This is a hub and broadcasting, basically it transferring the data packets to PC1, PC to Mac, to PC2, PC3. Okay, so this is how hub is basically work. Okay, now second point is that it does not analyze or manage traffic, it simply pass data along. The hub basic disadvantage, you can say, that it didn't manage traffics. It basically get all the data. For example, PC1, you have to transfer data from PC2, so it didn't process anything. It didn't assign any MAC address or basically a number, a series. Okay, it just take data and send it to all, to server also, to Mac also, to PC also, to PC1, PC2, all PCs. Okay, so this is a disadvantage. Now it operate at layer 1. Hubs work at physical layer of OSI model. So basically if you not know OSI model and layers of it, basically you can see the video in my playlist about OSI model and different types of model which is being present there. Okay, now second point is that it is a half duplex communication. What is a half duplex communication? Where devices connected to hub cannot send or receive data simultaneously. Okay, just basically one, when one device send data, the other has to wait, and when the other one has been sending data, the other side person has to wait. Okay, so there is not just like in your phone. Okay, what happen when you call, there is a full duplex communication, means the sender also saying at the same time and the receiver also saying at the same time, and the data is being processed in real time to the both the sender and receiver. Okay, so this is called as full duplex communication, where you don't have to wait to for other person so that he can speak. uh, okay, you are getting my point. So this is a half duplex communication. In hub there is a half duplex communication where the sender has to wait for, sender has to sender, when sender is sending the data packets, receiver has to wait, then the receiver can send the data when the sender completed his data sending packet completed. Okay, the process is completed, so you have to wait. Fifth point is that there is no intelligence. Unlike switch, hubs cannot differentiate between devices or learn their addresses. So what really is switches? Okay, so before jumping to that point, uh, we once again just know the reason to develop the a hub. Okay, so development of hubs are driven by the need to connect multiple devices in the local area network. So what is LAN? Basically this diagram, when one PC, second PC, and this all being connected to a hub, it is called as local area network, because there is multiple devices are there and they are being connected in local mode. Okay, during the earlier days of networking, but no, it is not no use, because now it is no of use, because switches in same way provide faster and profound features in it. Okay, so switches has a more profound features than the hubs. Okay, now the second question, next question arises, means if you connect two PC with Ethernet cable, then what is the use of hub? Okay, so this question is also arise. Basically we knows that if you are using a Ethernet cable, okay, you can connect the two PCs, but the limitation of it is basically you are connecting just two PCs. Okay, for example, this PC and this Mac is being connected to Ethernet cable, and yes, they can share the data through it, but the limitation is that only the limited amount of data is being shared. You cannot share, I mean, the limited amount of data is there also. But the problem is that if there is multiple PCs, if you have to share with multiple PCs, for example, thousands of PCs or hundreds of PCs, for example, there is a cyber cafe, or basically there is a big infrastructure, okay, where there is a company is running, where there's have to transfer data to multiple PCs at the same time. Hundreds and hundreds of computers are there, PCs are there. So at that structure, you cannot the Ethernet cable. It is just ridiculous. Okay, so for that reason, hubs and switches are work profound and have an edge. Okay, so this also you have to know that if you have only two PCs, okay, you can just use the Ethernet cable and share data with it. Okay, now uh, so if you are using a hub, okay, so no additional software is needed for basic communication. Okay, these are some basic settings how you can do it. Basically, you have to just give a static IP address to that particular platform. Then in control panel, you go to network sharing. It basically a simple process. Okay, nothing more. And once you are connected, just basically you can go to the network and sharing center and change advanced settings sharing, enable file and printer sharing. Okay, once you enable that, you can access the share folders in your PC. Okay, so very basics and nothing much. Okay, very basics. So once one more question arises, if you can connect two PCs basically with Ethernet cable, then what is the use of hub? Because in that case, two PCs connected, but with hub or switches, you can assign multiple PCs to it and also run internet in them. If you connect the switch hub to router and broadband, okay, so yeah, you have an edge. For example, you have to run the internet in multiple PCs. For example, there are hundreds of PCs, and you have to run the internet in all of them. And you also know that router only has 5 point. So if you want to connect multiple routers, multiple broadband, multiple PCs, so in that atmosphere, a switch is so much profound, and in that occasion, switch can work wonders. Okay, so what is the use of switch instead of hub? So basically, why we gonna use a switch when we already have hub? So let's see, there is a large networks. Okay, in network with multiple devices, which handle traffic more efficiently and reduce congestion, unlike hubs that broadcast at all, to all. Okay, so the biggest failure of hubs, you can say that it broadcast its message to all the people at once. Okay, for example, if, if there is a data which is a very valuable, okay, in a big companies there is a valuable data, and if you are using a hub, okay, so whatever you are sending, it basically transfer to all PCs. Okay, so can you imagine the level of security labs in there? Basically, everyone can access the data and they can use it whatever form, whatever way they want to. Okay, so these are a very security concern. Okay, for that reason, switches is being developed because there is a large network. Basically, first of all, it assign the MAC address. Basically, with the help of MAC address, it basically assign or transfer data to particular PCs. For example, a PC MAC address is 198.1. Okay, we are using example. Okay, don't get serious. 198.1, and there is a second PC that has 198.2 MAC address. Okay, so in that occasion, you can see that basically if they both have to just communicate, so only they can know what message is being sent by 19.1 to 198.2. No other PC can get their message in switch. But in hub, multiple PCs, multiple, even they both are just communicating, but everyone is getting the uh, that message what they are talking about and what they're communicating, what the data packets are. So this is a very really a security concern. Okay, now second thing is that a switch is also good in handling the traffics. For example, if there is for example 198.1 PC sending multiple packets to multiple PCs at once. Okay, it is sending data to PC 69, to PC 31, to PC 11, okay, multiple. So it can just take that information, store it in his RAM or whatever flash memory, and for that occasion, it once the congestion is reduced, it then processes the data to other PCs. So this is an advantage, because in large network, in multiple PCs, basically cannot process the things on large scale, but switch has advantage over it, and they can surpass that inefficiency of hub. Now second point is a high speed communication. Switch support modern Ethernet standard, okay, including gigabyte Ethernet and beyond fast data transfer for sorry and beyond, okay. For faster data transfer, you basically switch is more good, okay. Hello. So here we are, okay. So if you want to connect to PC with Ethernet cable, you gonna connect it, okay. So this thing we clear in our mind. Now advantage of using a switch over a hub, this topic we completed, okay. Now yeah, there is a full duplex communication in basically in switch, okay. By mean it mean switch allow device to send and receive data simultaneously, okay, which is essential for tasks like video calling, VoIP calls, etc, etc, okay. Now the thing is that why we gonna use the switch more rather than a hub, because for video streaming, for calling, for full duplex communication, switch is a better medium rather than a hub. Then improve security, since switch forward data only to the intended recipient, they prevent unauthorized access to data being sent across the network. So as we all know that in switch, particular person which has to be which MAC address being intended to send, only that person get the message, not the all the person which are being connected to the network, okay. But in hub, basically this not happening. To all the person who are being connected to the hub, the data is being sent to all, and definitely they can access it, and it is not also not being secure, okay. Now fifth point is that it has LAN support, means manage switch support virtual LAN, okay. So basically you can easily manage it using basically software, and or also by without software also you can just connect directly to the switch, and you can manage it directly using command prompt, okay. Now the thing is that there is something more to it, like there is a PoE switch also. Now we get what is PoE switch versus switch, okay. We know that what is switch. Now we want to know that what is PoE switch means, okay. So PoE switch is power over Ethernet, what really it is, okay. So PoE switch basically is a something which send data packets also, and with data packets it allow you to just connect your power also, means send power and data to connected devices, example IP cameras, VoP phones, wireless access point. For example, there is a multiple cameras you are been setting up, IP cameras you are setting up in your home, so you also need that you also need to that power that camera, okay. So if you're separately powering it up, it takes so much resources, and it's not viable, okay. Rather, if you're connected just all your camera to PoE switch, where just from PoE switch all the power goes to the camera, and through that you can access, you can just power the camera, and you connect that PoE switch to your CCTV panel, NVR, and your camera run very well, okay. So this also second point is that it simplified the cabling, means eliminate need for separate power adapter for your device, okay. Just I am said this earlier, that if you want to use the switches, not PoE switch, okay, in that case you have to just use the power separate power adapter for every IP cameras. Okay, and that is just gonna increase your bill. Okay, now third point is that power management has built-in power management to regulate electricity to connected devices. Also, even you are using the separate adapter for all the devices, there always some power issues, because sometimes more power comes, sometimes low power comes. Okay, but in PoE switch there is a separate department to manage the power, and it doesn't overload or limit the electricity. Okay, it just regulate it in well manner. Use case in IP camera, in calling, in Wi-Fi access point, in all those places you're gonna use the PoE switch. Now regular switch only transmit data packets, not cannot supply the power, and they require a separate power source uh, in that case. Okay, for general networking, like PC printers, load power dependency. Okay, now we get all the thing. Now just we look inside what is really inside switches. Okay, because although we understand how things work and all that. Okay, so now let's see what really inside a switch. So as you can see, there is so many components, but we gonna follow only the main component. Okay, which really constitute our switch. So the main component in it is switching fibers. What really is switching fibers? Switching fibers is the internal structure that connect the various port of switch. It is responsible for transferring data packets from one port to another at high speed. It provides the backbone of data routing and determine the overall capacity and performance of the switch. So basically you can see this little threads. Okay, these are just very important components, and basically these are the one through which our data packets are being transferred to high speed. Okay, so switching fibers is an internal structure that connect the various port. As you can see, this port is connected to this port using these switching fibers. These are small fibers. Okay, small fibers which basically connecting the two ports together, and they are the backbone of data routing. Okay, what basically mean data routing? You can route the data, you can route the data packets from one switch to another. Okay, and determine the overall capacity and performance of the switch. So basically if you want to know your overall capacity and performance of the switch, it is just the switch, the basically the switching fabric quality, which gonna determine how well your data is being transmitting from them. Okay, now basically it is hiding inside the PCB, but it's work like a mesh which help in transferring data. Switching fabric, it is a part of internal structure of switch or router, and while it's physically integrated into PCB. Basically, as I said, it is integrated into PCB. PCB means printed circuit board. Okay, PCB means printed circuit board. As electronic pathways, it work like a highly organized mesh of interconnected routes. These routes allow data to efficiently flow between inputs and output port without colliding and bottlenecking. Okay, so these are the things. Now second point is that network ports. As you know, there are RJ45 connectors for standard Ethernet cables. What these RJ45s? Let's see. Yeah, this one. Okay, so this one, as you see, these are the RJ45. Okay, these are RJ45, and these one are the RS232 ports. As you can see, it has 9 pin serial port, also called as DB9 connectors. Okay, these are the older one. Okay, now we come to the third point, third main component of the switches, which is ASIC, application specific integrated circuit. Okay, so what it really do? It is a specialized type of integrated circuit IC designed to perform a specific task or function rather than serving general purpose. Okay, rather than serving general purpose like CPU. It like all we all know what CPU does. Okay, basically it uses 0 and 1 binary to communicate and perform the mathematical functions. Okay, but in basically AIC, application specific integrated circuit, it is being designed or it is being configured to just process one specific task which has to be done. Okay, so custom design AIC are designed for a single specific functions such as processing data in network switches, manage power in electronic devices, or even mining cryptocurrency. Okay, so we just custom design this is a ASIC. Okay, application specific integrated circuit. So in exam or in anywhere, just they're writing the ASIC. Okay, so you have to know application specific integrated circuit. IC basically is integrated circuit, and then A is application, then S is specific application specific integrated circuit. Okay, now first point is that custom design, as we know. Second point is the high efficiency, because they are designed for specific purpose. AISCs are extremely efficient in performing their task, consuming less power and space compared to more general purpose chips. Okay, now third point is that high performance. As you can know that ASIC can process faster than general purpose chips because they optimize for a particular task. So if a chip basically is optimized for a particular task, it gonna process or it gonna work more way efficient than the general CPU, because a general CPU is being just a random thing. Okay, random things he has to process. But if a particular chip are being assigned to a particular task, so it revolve around that. Okay, then the cost. So yeah, ASIC can be expensive to design and manufacture initially, but due to the custom nature, once it is being a mass production, it can be cost efficient, and since they optimized for a single purpose. Okay, so in which types and in which area does the ASIC is being used? So basically in a networking equipment, in Ethernet, in networking equipment, in Ethernet switching routers, ASIC are used to handle the switching or routing of data packets efficiently at high speed. Then second point, in consumer electronics, many smartphone cameras and gaming console has ASIC to handle specific tasks like image processing, sound management. So basically a specific task are being assigned to ASIC, and it's gonna handle it more faster and good way. Okay, now these now we're gonna know that cryptocurrency mining. Okay, so just like Bitcoin mining, for example, it uses the ASIC that are optimized to solve the cryptographic puzzle involved in the mining, making them more efficient than the CPU or GPU. Okay, so yet simple question is that we have CPU, we have GPU, which is so much advanced and using billions and billions and even trillions of transistors. So how the ASIC are being more efficient in solving these problems? Because they are being assigned to do specific tasks. That is a not case with the GPU and CPU. Okay, they are general purpose, and you are using them for a specific purpose, so their power is being reduced. But in ASIC, they knows, okay, application specific integrated circuit, they knows what they have to do, and they're gonna do that. Okay, in automotive industry, for example, in controlling engine performance or managing safety systems, the ASIC are being helpful. Now there is a memory, RAM and buffer memory. Okay, these are the also important component of switch. Basically inside switch, RAM is being used to store MAC address and other information about the devices to connect to it. The buffer memory is used to hold the data packets temporarily, especially when there is congestion or delay in forwarding. Okay, then other thing is the handling WAN, virtual local area network, as keep track of which ports belong to which VLAN, virtual local area network. So this information is stored in RAM to quickly manage and isolate traffic between different VLAN without mixing the data from one virtual local area network with another. Okay, then RAM sizes, what are really is the RAM size? So basically the switch which we gonna use or which we are using in our homes use simply between 64 MB to 256 MB. So but it is not the case that only this the switches are being used in MB itself. There is been occasions when on in present level, if switch is being used to handle even hundreds and thousands, in that case it is been in GB, 2 GB, 3 GB, or even more. Okay, so there is no hard and fast rule that it has to be, or it is fixed that only this amount of MB is being used, particular to design, particular to pattern, particular to uses. The RAM size is being differ. Okay, now there is a cooling system, fan is being there, LED indicators next to each port that show connectivity or speed. Speed can be on 10, 100 or 1000 Mbps. Okay, then there is a flash memory also, because RAM is okay, but flash memory is being already, software is being included in it, and it knows all the thing in advance. Okay, now there is a management interface or manage switches, or we can call as console port. What really is console port? So console port is nothing, it is just a part given, as you can see in the image, it is a part given, so that basically what happens, console port on network switch is a physical interface that allow network administrator to directly manage and configure the switch. Basically, if the network administrator want to just directly configure the switches, how he can do it? Basically, he can do it using the console port, and if he has this console cable, okay, either this one RJ45 or RS232. Okay, using both one, he can just configure our console. What really he can do the initial setup or when troubleshooting it. So many times it has to be, there is a places when he has to troubleshoot something in switch. So basically he can use the console port and can do it. Okay, he can typically use or access the through console port using the command line interface, CLI. So basically, what is command line interface? As you know that in Windows there is CMD, same like that there is a command line interface in router or in switch also. Okay, so using that he can access the network and can do or change the things. Okay, so console port is used for set up a new switch that isn't yet connected to network. Since switch doesn't have IP address initially or other settings in place, you can't connect to it remotely through the network. Then second one is the console cable. You connect directly to the switch and access in its command line interface, CLI from nearby laptop, desktop. Troubleshooting, yeah, you can use it for troubleshooting if there is a trouble in your switch. So as you can see, what really is command line interface, CLI. CLI doesn't have a graphical user interface, GUI. So instead it uses a plain so it uses a plain text, direct access to device function, flexible and powerful. It has a command to modify advanced setting that cannot be accessed using the GUI. So basically, if you are using CLI, you have more advanced features. So basically it's like this, it is being seen. Another thing is that the data travel in the form of packets in network like switch and router. Why? Because this method is more efficient for breaking up and transporting large amount of information over different types of physical and logical networks. Okay, if it is been binary, it cannot be transferred, so it has to be made in data packets, so they can really transfer it more correctly. Okay, also it efficient your transmission, avoid congestion and delay, error handling. If packet is lost or corrupted, only the specific packet need to be resent rather than the entire data set. This is the advantage. This improves the reliability. Okay, think for a second. If it uses the binary, even one binary is been lost, your whole data is been corrupt. Okay, so can you imagine the amount of displays or error it create? So for reducing that, they using the packets, data packets. In that case, even a specific data is been lost, it can be recovered easily. Okay, now traffic management, network can prioritize packet based on their importance. So this is the important thing in that. but really inside a packet. So inside a packet there is a structured arrangement of data that is essential for communication between the devices. Okay. So as there is a header, okay, so the header contains the metadata about the packet, and it is crucial for proper delivery of the data. Okay, so header contains the metadata data about the packets. It has the source address, means the IP address or MAC address of device sending the packets, destination address, from where it is been sending or where it is being sent. Okay, both thing is being in header. Then packet number, if data is been broken into multiple packets, this identify the sequence in which packets should be reassembled. Then fourth one is protocol. This type of communication protocol being used like TCP, UDP, ICM, these are being used. Then fifth one is time to live. Okay, the maximum time or the number of hoops a packet can take before it is discarded. Each router increases the TTL, preventing the infinite loop. So basically it has the maximum time or number of hops a packet can take before it discarded. Okay, so it has advanced features in it. Then there is a checksum, a value used for error checking. If there is an error, you can use it for that. Okay, for checking for that. It ensures that integrity of data is being detecting if any bit is corrupted during transmission. So for example, if your data is being corrupted while transmitting, so using checksum, it can identify where it is been broken, where it is been wrong, and it can correct it using the checksum values. Okay, so these are been important. In header you have source address, you have destination address, you have packet number if something is being missed, you have protocol, basically which types of protocol you are using, TCP, UDP, etc, etc. There are different types of protocol, and you can see what different types of protocol in my playlist video. I made each and every video about TCP, UDP, ICPM, and many more others. Okay, then second one is the payload. The payload is the actual data being transmitted, so it is being inside the data packets. First it thinks a header. Okay, in header these all are being there. Okay, inside after the header there is a payload, and after the payload there is a trailer. Trailer is something called footer, come at the end of packet, and often contain error detection nodes. Okay, what really error detection node codes is basically error checking data frame check sequence, or CRC. Okay, this used to verify that the packet has been not been corrupted. Okay, so it verify that it has been not corrupted. Okay, without it didn't know that either it is being corrupted or not. Okay, if error are detected, the receiving device can request retransmission of corrupted data. Okay, if error is being detected, they request for retransmission of data. So basically it checks, and if there is been a corrupted packets it found, it transmitted. Okay, now example of packet structure for TCP IP. For packet transmitted during TCP, the packet might be broken into layers like this. Okay, so in first Ethernet frame, so there is been types of way. So this packet transmitting using, if you are using the TCP IP protocol, the packet might be broken down into layer like this. Ethernet frame layer 2. Okay, data link layer. What is inside it? There is Ethernet header, contain MAC address for source destination. Ethernet payload contain the IP packets. Then IP packets, inside the IP packets there is a layer 3 network layer comes in IP packet. They contain the source and destination of IP address, TTL, and more. IP payload contain the TCP segments, and after that there is a TCP segment. There is a transport layer. In TCP header contain port number, sequence number, acknowledgement number, etc, etc. Then TCP payload, actual data being transmitted, part of file or message. Why are packets structured in this way? So basically, efficiency breaking data into small packets allow different part to travel along different network routes and resemble at the destination. Basically, we are using different types of routes, and we're gonna assemble it at the destination. This improves the speed and reliability. Okay. Then second point is that error control. If packet is lost or corrupted, only that specific packet need to be resent, not the entire data stream. This has to be noted. Routing flexibility, packets can take different parts across the network and still reach their destination depending on the conjunction and the best route at that time. So this is all, and I think you got what really is hub and switches, and what is inside it, and how it gonna process things, and what really things are. So that's it for this video. If you like this video, you can thumbs up and you can comment, and if you think there is some improvement in our video, and if you didn't understand any specific topic, any specific thing, you can comment it down and we're gonna improve on that thing. That's it for this video, and thanks again for watching it, and we're gonna see you in the next video. Thank you.